Welcome to the Subverse. I'm your host, Susan Mathews. This is a podcast where we journey from the cosmic to the quantum, from forest soundscapes to fragile oceans, from the songs of whales and trees to the secret world of microspecies and microbes. In this season, we will cover the element of air. The air we breathe, the clouds that enchant and bring rain, the winds that blow and even stoke wildfires and cyclones, aerosols, particulate matter, microplastics, dust, ocean currents, airborne diseases, and of course, the atmosphere that blankets us. Air is media, it is matter, it is everything. Temperature, weather, smell, light, electromagnetic forces, space, horizon, the power of flight, the aerial and the airy, are a source of endless fascination and now of major concern and worry. To give the season oxygen, I have been researching, and while I could go where the wind and my wings take me, I have let my imagination and interest rest on a few choices. A few conversations which for me might not cover the expanse, but give you, our listeners, a playlist of subjects which I hope will enthrall you as it did me. The season starts with my guest, Roxy Mathew Koll, a brilliant climate scientist from the Indian Institute of Tropical Meteorology in Pune, India. His research focuses on climate change and extreme weather events in the Indo-Pacific region, with significant contributions to understanding of Indian Ocean warming, monsoon dynamics, heatwaves, tropical cyclones, and their impacts on public health. In this wide-ranging conversation, we discuss the atmosphere and the intricate relationship between air and climate. We look at future scenarios for the Indian Ocean in a context of intensifying marine heat waves. The conversation ends with a look at climate education and turning schools in India into weather stations. Roxy is that unusual blend of rigorous scientist and amazing science communicator who speaks with empathy, heart, and an outlook prioritizing action and deeds. This conversation was also proof of something I have found in this elemental journey in the past few years. Quoting John Muir, "When we try to pick out anything by itself, we find it hitched to everything else in the universe." I hope you enjoyed the conversation as much as I did. Roxy, thank you so much for joining us and welcome to the Subverse.
Thanks a lot, Susan. It's a pleasure to be here.
I would like to start with a very general question on air and climate. If we see the Earth's climate as a body, it relies on many interrelated parts to function. And the atmosphere in particular insulates Earth by trapping heat and transporting heat and water vapor. Now, all of this is going through nothing short of a cataclysmic man-made upheaval. So can you summarize what are, in your view, some of the clear and present dangers we need to keep in mind on this atmospheric front, so to speak, along with the other parts of the Earth's body that are also implicated?
Yeah, we always say the atmosphere is like a blanket, and the thicker the blanket, or depending on the material, you will trap more and more heat. And that's what is happening right now with more and more greenhouse gases like carbon dioxide, which has the properties to vibrate at a high frequency. That's the reason why it traps more energy. And carbon dioxide is essential for life on Earth, because if we did not have these kind of greenhouse gases, the average temperature of Earth would have been close to minus 15 degrees Celsius. And because we have greenhouse gases trapping some energy, we have some heat and warmth in the atmosphere, in the air around us for all of us to survive. This average temperature for several thousands of years have been around 15 degrees Celsius. And because humans have emitted through fossil fuel burning through industrial revolution starting from 1850s to the present day, through the industries, through the cars that we use, through multiple different ways, more and more carbon dioxide has gone into the atmosphere. And the atmosphere has absorbed more and more heat. It has changed the global temperatures, that 15 degrees Celsius. until a few years back, maybe the start of 2000 and 2010, the average temperature increase due to that emissions were about 1 degree Celsius. Yeah. Now we have reached a point, it is somewhere between 1.2 to 1.5 degrees Celsius. And probably we are moving far ahead as well. And this has made changes in the atmosphere above us in terms of the air circulation, in terms of the ocean circulation, because all this works with how the heat is distributed. And this heat distribution, though we say 1.5 degrees Celsius, that is just the average temperature for the surface temperature over the earth. Yeah. But if you look at different pieces of it, different air system components, like how much does the air absorb, how much does the ocean absorb, how much does the land absorb, how much does the ice in the polar regions absorb, it's all non-uniform. Yeah. And there we see a huge marked difference. We see that 93% of the heat absorbed from man-made global warming has gone into the oceans. And land, atmosphere, ice, and all together has absorbed less than 7%. And what we generally feel is only that 7% of the additional heat absorbed. And even over the atmosphere or over the ocean, it's non-uniform. And that creates gradients of temperature. So some regions are warming more. For me, I am in South Asia, in India, and it's covered on all sides by warming oceans. And tropics, there is much more heat now. And that changes the gradients across the globe. And that changes the way the winds work. For example, the trade winds in the Pacific Ocean, they are changing. The ocean circulation, there is what we call the conveyor belt, which connects all the oceans from the Pacific to the Atlantic to the Indian Ocean and way to the poles. So these conveyor belts are what distributes the heat, which is mostly generally accumulated over the tropics and the equator to the polar regions and so on. Yeah. The conveyor belt is kind of broken in recent decades, or it's weakening. We call it the Atlantic Meridional Overturning Circulation, or AMOC. That's because Atlantic has a major role in initiating this ocean circulation, which is not confined to just the surface. It's not just like currents in the surface, but connected to the entire ocean. And if you take the ocean is like average 4 kilometer deep. And in this entire ocean, in some regions, the water subsides, goes down, and then moves into some other regions. It reaches the Indian Ocean, then the Atlantic, moves to the polar regions as well. Yeah. So this moves over several tens of thousands of years. And if there is a change, if there is a weakening in this kind of circulation, it can accumulate more heat in some regions, and we see the global climate changing. Yeah. Similarly, we see changes in the atmosphere as well. The jet stream is changing, and it's also meandering more, resulting in more extreme rains in some regions. The monsoon winds have changed, which relates to many of us over here. Even though I'm a climate scientist, I go outside and I feel the impact of these changes on a day-by-day basis. Yeah. So we see the air and the winds around us changing, and correspondingly the climate, the rains that we receive, the temperatures that we feel, everything is changing.
Thank you so much, Roxy. And since our larger topic for the podcast this year is air, I think part of it is that air is invisible.
Yeah.
But with climate change, we see the visibility of its impacts. And here I have a question. I think for a lot of people, when they see 1.5 degrees or 2 degrees, they just look like small numbers. But if you had to explain, what is the difference between what you would feel at 1.5 and what would you feel at 2 degrees?
Yeah, exactly. So this corresponds to an global average over the surface, which means that for some regions it may be too high, for some regions it might be low. Yeah. So even though it is 1.5 degrees Celsius as an average, some regions it could be 3 degrees Celsius or more, that average change. And again, this is an annual average, which means the change will be accentuated for some seasons or some months, and maybe for some days. Yeah. So it's an average for daily temperatures across the year. And we would see this impact as heat waves over maybe 5 days or 7 days. In recent years, in the recent decade, we saw tremendous heat waves across Europe, across US, in India. We see on an annual basis in South Asia where people are impacted. So even though we cannot see air or heat or wind or anything or the humidity, it all works together. And here in South Asia, we see temperatures crossing 50 degrees Celsius in India, in Delhi. So 2 decades ago, in India and Pakistan, the population might be exposed to a temperature or a heat wave. For example, in April, May, June, just before the monsoon, maybe a heat wave of 45 degrees Celsius or 47 degrees Celsius. But now they are seeing 51, 52. And all this is masked within that 1.5 degrees Celsius. So that is one key thing. The other key thing is that even those average 1.5 degrees Celsius change has already made changes in the weather patterns that we see. We see the polar ice melting, the Himalayan glaciers retreating. So this leads to sea level rise. It's not just the ice melting that leads to sea level rise, but also what we call thermal expansion of water. The ocean is like 4 kilometers deep. And all this ocean is absorbing more than 90% of the heat from global warming. So it expands, the volume of water expands. So for example, like in the Indo-Pacific region, for South Asia, parts of Africa, Australia, this thermal expansion of water is contributing to 50% of the sea level rise. Yeah. So all this is due to that 1.5 degrees Celsius change.
Thank you. I'm keen on understanding more about these changes in ocean circulation or ocean warming driven by climate change. In your own work, you have noted that the Indian Ocean is moving to a near permanent marine heat wave state. I have to say that reading this particular article, it gave me chills.
Yeah.
And not in a temperature sense, but it really scared me.
Yeah.
And this is because the Indian Ocean is bordered by 40 countries and home to a third of the global population.
Yeah. Yeah, there's a lot of vulnerable population in this region.
Exactly, within this. And in these marine heat waves, periods of extremely high temperatures in the ocean are expected to increase from 20 days per year to 220 to 250 days.
Yeah. So just like you, it gives me also chills. But I want to tell the audience, all this climate change information, everything in the charts is going up in red colors. It can make us anxious. It can make us a bit too worried. It's a lot of darkness, but at the same time, there are ways in which we can work forward. So I want to start with that. The information that I'm providing help us to understand where we are right now so that we can take the precautions in the right sense. Yeah. So if we do not understand the heat waves over the land, heat waves over the ocean, we cannot work on adaptation. We cannot work on safeguarding the marine ecosystem or our own lives. So it's important to understand these changes in the ocean as well. Like I said, this region, there's a huge population around the Indian Ocean rim, 40 countries, more than 1/3 of the population, maybe between 1/3 and 1/2 of the population directly depends on the Indian Ocean. And their weather and climate is also affected by Indian Ocean because the monsoon system itself, it sources its moisture, its energy from the Indian Ocean. Yeah, it starts as the trade winds in the southern Indian Ocean, moves to close to East Africa, and then moves towards South Asia and East Asia. The Indian Ocean is a life giver to all this region. So if the ocean is warming, that means it will impact the monsoon. It can create cyclonic storms, and even heat waves over the land are connected with this kind of warm conditions in the ocean. So what we are seeing in the ocean is that we have data, we have scattered data from 1900s. Our data over the ocean during this time, all based on ship routes, data from voluntary ships, which have been collecting data through this period. Since 1950s, we started measuring more scientifically. Since 1980s, we have satellite data as well. Yeah. And we have been using models to fill in the gaps in this data as well, so that we can understand them better. So from this data, we see that the Indian Ocean is warming quite faster than the other tropical oceans like the Pacific and the Atlantic. One peculiarity of the Indian Ocean is that it is landlocked in the north. So unlike the Pacific and the Atlantic, which is open to the poles, it doesn't have that opening in the north. Yeah. So Pacific and Atlantic, through the same conveyor belt that I talked about, the Atlantic Meridional overturning circulation or the overturning circulation, it can flush out the heat from the tropics easily to the poles. But in the Indian Ocean, if you are getting more and more heat due to that global warming, if the Indian Ocean is absorbing as the other ocean, it cannot flush out the heat in the same manner. So this is a very simplistic explanation of why it is keeping more heat compared to the other oceans. And basically, it's a much more warmer ocean also due to multiple reasons, including this. And if you take the temperature of Indian Ocean, ocean temperatures are generally relatively cooler than what we feel on the air or over the land. And for the Indian Ocean, the average temperatures range from 26 to 28, 29 degrees Celsius. But in the recent years, it has warmed so much that most of the temperatures are now going above 28 degrees Celsius. And for an ocean, 28 degrees Celsius means it's suddenly favorable for enhanced convection or cloud formation or cyclone formation as well. So this is a gradual monotonic warming that we found in the Indian Ocean. But at the same time, there are these heat waves happening in the ocean as well. And this is something scientists started understanding only very recent, only in the last decade or so, this term marine heat wave was coined. This was for some of the events close to the Indian Ocean, close to the Australian coast. Some of the Australian scientists coined the term marine heat wave because they saw some of these ocean currents are stalling. So when they do not move as fast as earlier, the heat piles up. So because it doesn't get transported to other regions, this results in periods of extreme temperatures. So instead of maybe 26 degrees Celsius, you will get 29, 30, 32. These are marine heat waves. Some marine heat waves may last for a few days, but sometimes they last for months. There was a marine heat wave in the Pacific, this is the Northeast Pacific, close to the US coast. It lasted more than a year. It was called the Pacific Blob. And it resulted in the huge loss of fisheries for the US during that year. I think it was in 2020s. I don't remember exactly which year it was. We now see similar episodes in the Indian Ocean also, across the Indian Ocean. And this is a direct impact of global warming because ocean has absorbed all that heat. And until now, it used to be maybe 20 to 50 days in the last 2-3 decades of marine heat waves. But we can use the same models to foresee how the ocean and climate system might change in the next several decades. We have different narratives for the future. We call them shared socio-economic pathways. It's basically emission pathways. So, okay, there is a pathway. We will not emit any more carbon dioxide. There is a pathway, okay, in a moderate level, or there is almost like a business as usual pathway with the high road. Yeah, we are going on that high road actually, even now. Even after so many negotiations, it was a COP30 recently, which means 30 years we were talking about working on reducing emission, but nothing else transpired over there. Yeah. So from that, if you go through that highway, if the Indian Ocean has warmed like 1.2 degrees Celsius in the last century, in the next 60, 70 years, it can warm up to 3.8 degrees Celsius from now, which is like a huge change and which can result in a tremendous amount of intense marine heat waves. So what we are seeing is that the way we are going, we might see about 200, 250 marine heat waves by the middle of the century. That's around 2050, 2060s. That's not too far. So I'm like 45 years old. So maybe by the end of my time, I would see these extreme marine heat waves releasing extreme weather events because marine heat waves we see have a strong tie-up with cyclones. So if you have a marine heat wave, there are high chances, especially in the Arabian Sea, that if the wind conditions, the atmospheric conditions are also favorable, it can trigger extreme cyclone. And not only trigger a cyclone, the way the cyclone intensified, sometimes a cyclone intensify overnight in less than 24 hours. We call it rapid intensification like cyclone. So these kind of events, maybe we will all be facing.
Thank you so much, Roxy. And I completely agree with you. It does feel like the years are closing in on us.
And it's us. We always talk about grandchildren and all. It's for our grandchildren and future generations. No, it's for us. I mean, when we are at our most vulnerable stage, we will be impacted by this. If you take one of the recent heat waves in Maharashtra, the people who died were all people on 60s, 70s year old.
That's interesting. Also looking at vulnerable populations by age.
Yeah.
And I was also just going to add that fossil fuel production has not lessened in any way. Plus, we also have increasing war and weaponry, and all these also add to carbon emissions. So that doesn't help.
Actually, in our talked about the shared socio-economic pathways, right? One of the pathway or scenario is called regional rivalry. Yeah. And that is when countries are not cooperating, they are at war with each other, which means climate mitigation, adaptation, reducing emissions, and also our innovation, science and technology, everything goes down, takes a back seat. And that results in more emissions. Yeah. And our adaptive capacity also goes down. So we are seeing exactly that.
Here, I also had a follow-up question, Roxy, which is we're talking about the impact on humans in terms of increased, let's say, cyclones and whatever happens on land. And you also talked about fisheries. It's also going to affect livelihoods in a big way. But I also don't want to forget life in the ocean. What happens to that life in a marine heat wave? And I have read recent articles about this darkening of the ocean. If you could speak a little bit about this.
Yeah, definitely. So the first impact of all these heat waves are on corals. Yeah. And we might think, okay, these are like some lifeless things in the ocean far away. But if you know about corals, you would realize that even though corals occupy only 0.1% of the globe's surface, a quarter, 25% of the marine biodiversity depends on corals. And a lot of these corals are getting killed because of extreme temperatures and marine heat waves. So what is happening is that corals live in symbiosis with algae species covering a membrane. We call them zooxanthellae, covering this coral. So that gives them the color and the shield and the protection. Yeah. So if you see a pink coral or a green or a blue coral or these kind of colors, these vibrant colors, this is from the zooxanthellae, the membrane covering them. And this membrane also helps in doing some of the photosynthesis, absorbing that food. So when there is extreme heat, the corals have a very particular tolerance. So when the temperatures cross a particular threshold, the membrane gets peeled off and only the exoskeleton white part of the coral remains. That's what we call coral bleaching. The corals get bleached of their color. Now, sometimes the corals can regain this membrane and come back to life if the marine heat wave is a pretty short duration. But if you're going to have something like permanent marine heat wave or month-long or repeated marine heat waves, then these corals die because they are unable to revive themselves. They die. So a lot of coral mortality is happening. We have, in fact, lost a lot of corals in the tropics. For example, there is a peak dense coral zone in the Indo-Pacific close to Philippines, Indonesia, called the Coral Triangle. It's connected with the Great Barrier Reef. And this cascades to other species. So you have the smaller phytoplankton in the ocean. Phytoplankton are like the microscopic plants. So I would like you to take a deep breath, Susan. So 50%, half of the air that you are taking inside, the oxygen comes from these phytoplankton, which was produced several tens of millions of years ago in the ocean. It's not just the trees around us that is providing us this oxygen, it's this ocean and the phytoplankton. So whatever we are getting, whether it's the water, the air, the oxygen, everything, our own life also, we connect to the ocean. So what happens in the ocean, we need to be concerned about. So similarly, these phytoplankton species are also dwindling. We measure that using the color spectrum from the satellites. So from the satellites, we can measure the wave band between 440 to 550 nanometer, which is the color spectrum, particularly the blue and green spectrum. So if you measure that, we can have an estimate of how much of photosynthesis is happening in the ocean or how much of phytoplankton is there in the ocean. Yeah. And over long period, we see that over some regions, due to multiple changes, including ocean warming, the phytoplankton is reducing in some regions. Their species itself is changing. And this has even resulted in kind of darkening in the oceans, like a recent study from last month. This is a preliminary study, I would say. We need more studies like that. They point out that maybe there is some change in the phytoplankton. Maybe there is some change in the nutrients that they depend on, because phytoplankton depend on suspended nutrients in the subsurface. So they get light from the top and there is nutrient in the subsurface. That is the region where the maximum production happens, biomass production, or these phytoplanktons originate. And if there is some changes in this, either in the light coming or in the nutrients, some of these nutrients come through the rivers from the land, because rivers always carry some sediments. This carry nitrogen, phosphate also. Sometimes dust comes from the deserts and deposited over the ocean. That brings in iron. So these act as nutrients for this phytoplankton. So something has changed. There is more particulate matter, suspended particles in the ocean. The phytoplankton also has changed. So we see that in the color spectrum, it is going towards a darker blue rather than green or greenish blue. This may be a serious concern. And we see changes in the Indian Ocean as well. For example, in the Northern Arabian Sea, instead of the usual phytoplankton, we see something called the noctilucus, which is like bioluminescent phytoplankton. And these are harmful also. We call them harmful algae blooms. These are harmful for fishermen, harmful for anyone, maybe harmful for other fish species as well. So we see this flipping and transition of many species. I came across some studies showing some coral species are also transitioning because of warmer temperatures. Yeah. So all these cascades through the food chain as well, impacting humans over land, impacting other marine species. We see declining fish species or changes in fish species. Some fishes may be diving down deeper for cooler water, but maybe when they dive deeper, maybe they may not get enough algae or phytoplankton as well. Yeah. Some are migrating north because it is cooler over there. We need more data to understand these kind of changes. Yeah. So the impacts are large, but I would say whether it's coral or fishes, other than climate change, there are other factors also, like industrial fisheries. They have resulted in more depletion of fishes than climate change. I had a look at the tuna population itself. If you compare from 1950s to now, maybe we have lost more than 3/4 of the tuna population. It has come down because of industrial fisheries. So this climate change is an added stressor, which means that for regions like where you have more corals, which are hotspots for biodiversity, we should try to prevent coral mining, mindless tourist activities, and things like that. That can help save these corals. And we need more research in identifying those coral genes, which can help us replicating the corals for a warmer ocean tomorrow. Yeah.
Roxy, thank you so much. And thank you for reminding us of our breath. We often forget the air that we breathe. We can move back to land and speak about some of the land use changes that also contribute to all these problems.
Yeah, I think this is quite important because it's a polarized world, actually. And this polarization we see in climate change discourse and discussions also. Based on the convenience, we weave our stories. Sometimes you see narration of only climate change. Sometimes you see a narration of only land use changes, or sometimes you see narration of like high income countries like US, Europe. They have done this and we also have to do that, things like that. But we always need to have a comprehensive view, just like we talked about ocean warming and industrial fisheries affecting the entire marine ecosystem. Similarly, there are impacts over the land as well. So when we have floods, in India, we see politicians blaming climate change. because they don't have to take the responsibility of adapting locally. And maybe in US, they won't put the first blame on climate change because they know about the historical responsibility and they have to reduce emissions. So that's a major difference that I see very often. So in all our cities, not just cities, but rural areas also, the extreme rain conditions have increased across globally. But the way we have prepared our cities or farms or rural areas, they are not prepared to face these extreme rains in a very short time. One of the properties of global warming is that oceans are warming, there is more moisture, and this moisture is evaporated into the atmosphere. Warmer the air, the more moisture it can hold. We call it Clapeyron relationship. So if you look at a graph of temperatures going up, you will see the moisture also going up. So warmer air can hold more moisture. It can hold for a longer time also. So all that moisture coming from the ocean, it is in the air now, and it doesn't rain for a long time. And it moves as clouds towards land. So for example, take the case of South Asia, India with the monsoon. And it doesn't rain for a long time, and all of a sudden it dumps all that moisture in a few hours to few days. So that is like a month's or a season's rain sometimes in a few hours to few days time. That's the kind of extreme rain that we are seeing. So surely climate change, the impacts we are seeing, and more towards the tropical regions like the Indo-Pacific. We see that in a place like Singapore. We see that in a place like India. We see across the globe. And here it is much more faster because the tropical regions, the weather is fast moving. There is more energetics. Yeah. So the weather systems are developing faster. They are shorter systems. For example, in a 3 hours time, you would have clouds developing into multiple cells and dumping all that rain. And this means the predictability is also low. So people are less prepared. And this is the reason our forecasts sometimes fail compared to where you are in Switzerland or in the US. There, the weather systems are larger systems, which are relatively slow moving compared to the tropics. So very often we say, why can't we predict like the US or Europe? Here, if the Met Department says it's rain, you don't have to take an umbrella like that. Yeah. Mm-hmm. But it's because of this energetics in the tropics. So we see this kind of impact happening over our land. And here, what has happened over the land? Rapid urbanization without proper planning. And maybe it's because each project in a city or in a district is taken up individually without consulting with other departments. So if we build a road, we just build a road without thinking about the environmental climate impacts. And we squeeze out rivers, we squeeze out marshy lands and mangroves along the coastal regions, which could absorb a lot of that excess water from heavy rains. So all of a sudden, we see that our cities are flooding even with short amounts of rainfall. So we need to actually make sure that there is more of a porous, spread out land and meandering rivers that can absorb this kind of water. We need to save our rivers. We need to save our mangroves, which absorb a lot of this water. And there are many examples. Even airports are built over marshy lands. So this is happening across the globe, particularly in South Asia, where the adaptive capacity is low, more population is there, and planning is much more haphazard.
You've often written about education and early warning. And one of the lines that you've written, which is really stuck in my head, which is making every school in India a weather station. Yeah. It's really a beautiful idea which resonated with me and really stuck in my mind. So if you could speak about this.
I'm delighted to hear that.
I just love it. And I have been telling everybody that I meet about this.
That's my pet project. It's a concept, or it can be like a toolkit. So school is a representation of any institution where many people come. And what we see is that if children grow up with the awareness of how the climate is changing, they know how to monitor or at least understand the weather around them. They can make provisions on how to adapt and take precautions. Like the Met Department on a daily basis, they say, okay, today it's 10 millimeter rainfall. Tomorrow they say it's 100 millimeter rainfall. But even adults do not know what this is. Yeah. But if the school children just get hold of a rain gauge, it can even start with a plastic bottle just marked with the levels and kept in an open ground, and they can measure the amount of rainfall on a daily basis. They will understand how much rain can cause floods in their region, or how much will the river swell because of this kind of rainfall in that region. And this is quite important. And they will also understand the seasonal cycle. When do they need to preserve more water? Okay, this year we saw the rain has been lesser, so we need to save some more water. So it is based on this concept that we derived this concept of climate equipped schools. So think of a school assembly in the morning. The children are coming out and saying, okay, in the last 24 hours, this was the maximum temperature. This was the minimum temperature. This was the amount of rainfall. So they will learn to adapt their lifestyle, their daily routines and all based on that. So if it is a heat wave prone region, they'll be able to see the peak hours when the maximum temperature is. They can cut down the school hours. This all connects to real life scenarios. I remember 2023 heat wave, 2024 as well. My own kids, they were coming back from school at peak heat wave time, around between 2 and 3 p.m. When they come home, they are in a heat stroke situation. So this happened, then we had to contact the school. Okay, this is happening. There was forecast, there was warnings. So please cut down the school hours. Then they cut down the school hours. So this happened in 2023. Then I raised awareness and all people followed. Even the Ministry of Education made some circular about that. But this was for 1 year. We need policy. So the next year, same thing happened, but the school principal was different. So I had to again reach out to them about this. But this time their perception was different. So it was kind of difficult. We need policies. Anyway, all this can be helpful if we equip the schools themselves to understand the climate. So they can monitor the temperature, monitor the rainfall. They can have water harvesting, groundwater recharging, and also maybe solar panels if they have the capacity to do that. They can have other means of adapting and mitigating climate change. So already doing part of it in Kerala and Maharashtra. Some schools are partially climate equipped. So it's based on the challenges and the capacity of that region or those schools. And it's beautiful. And we have a network now.
Roxy, if I may just ask here, because in India, we also have huge inequalities in terms of class and caste. So how do you translate that into school policies that you're developing?
Yeah, so the expense for at least some of these things like a rain cage, you can make a rain cage, or even if you buy manual rain cage, you can get it in 1,000 rupees. So some of the expenses are so low. So if you take at panchayat levels, many panchayats and districts have already allocated money for environment and climate protection and so on. So even if you use a little bit of that money, we can have this kind of setup in some of these schools. Yeah. So regardless of their capacity, some of the provisions can be made. And groundwater recharging and all, it is about filtering the water coming through the roofs and getting it to the ground. That can be done in very cost-effective way. So there are cost-effective ways, regardless of caste or the income of the families or the region or the school capacity. Some of the things can be easily done. It's just for the schools to know, okay, there is this thing, this possibility for them to take up and embrace. And there are many funders and sponsors also. We didn't talk about corporate social responsibility or greenwashing. Yeah. So there are many organizations that have a lot of money, which is meant for adaptation and mitigation for India. So connect these two.
Roxy, I'm going to just ask you for a few messages that you might want to give to the audience that you think might be very important, both in terms of the analytical, but also the practical.
Definitely. In a practical manner, I would say, whether it's in a larger sense or an individual sense, generally across the globe, there is a lot of focus on climate mitigation compared to adaptation. So there are two ways in which we can work with respect to climate change. One is mitigation, reduction of emissions. Now, that has gone beyond the scope of an individual or a state, or sometimes I would say even a country. We need global level cooperation to reduce emissions and cut it down. And that is not happening also. The commitments are not enough, first of all, and countries are not following those commitments. So globally, we have failed. Yeah, we can do so much on lifestyle and in reducing emissions. That has to be done, but there is less focus on adaptation. It is not very clear also. Because for mitigation, we have clear pathways. Okay, these and these lifestyles, or these and these public transportation, renewable energy resources. So these can reduce emissions. But for adaptation, we need to understand very locally. The adaptation requirements will be totally different based on the weather and climate and the changes and the geographic conditions and the population residing there. Yeah. So at a village level itself, what we call panchayat level itself, we need to have that adaptation strategy. And it's possible. We have the data at that level. It shows, okay, the temperature is changing by this much. The rain is changing by this much. We have daily data. There is so much of meteorological data. We can have a lot of insights from this. So, and we have the projections, what we call the future data also on how it is going to change. So we can prepare our farmlands, our daily life, our houses. So if you're building a house or if you're building a highway, any infrastructure, or if you're preparing your crops, this should not be based on past changes. This should be based on how it is going to change in the future, because our flood line is changing, our cyclone is changing, heat wave is changing. And it is possible to have an understanding of that and prepare for that future heat wave or future flood. And we can do that. We need to do that and make sure that the people you elect, even at a local level, at panchayat level or a municipality level, city level and state level, or at all these different administrative levels, the people you have there at administration and also at policymaker level are aware of these changes, are ready to prepare the administrative unit at that level. So I think that is very important, this kind of adaptation at the local level. We always think climate change is happening, global warming is there. Okay, I will use cycle or public transport. That is good. But at the same time, we have to prepare ourselves, because maybe you are getting down from that bus and you are getting washed away with that flash flood. And that has happened in Pune. So if we don't prepare our environment, whatever we do, we are going to get flushed out into the sea, back to the ocean. So we need to be prepared. And we can. We have the data, we have the capacity. It's not lack of funds or money or anything.
Thank you so much. We really appreciate the tremendous work you're doing. It's really been an honor to have you as a guest.
It was a wonderful exchange. It also keeps me thinking about what we can do to find some light at the end of darkness.
Thanks to Roxy Mathew Koll for sharing his thoughts with us. The Subverse is the podcast of Dark and Light, a digital space that chronicles the times we live in and reimagines futures with a focus on science, nature, social justice, and culture. You can follow us on social media at Dark and Light, Zine. The Subverse is produced for us by Tushar Das. A special thank you to Julian Way, who helped me record at Kumquat Studio, and Daniel Schwenger for helping organize this. So long, and thanks for listening.